First of all, hello everyone, and thanks for taking the time to attend this evening. I hope that everybody is managing 2020 as reasonably as well as can be expected. I'd like to share with you a component API approach that I arrived at, which takes a bunch of cues from React's native input. And so here we have our humble input. It simply allows a user to type in a line of text. And I like to think of this as the component that launched 1,000 web apps. Countless developers, self-included, have been lured into React by the kind of elegant appeal of the uncontrolled input. And using the native input, one can get visuals on the screen almost instantly, and it's almost effortless to make it interactive. This is particularly because it's actually optional to specify explicit controls, which people will most commonly do by passing in like a value and an onChange prompt. So at the same time, the component lets the developer do everything that they need to do. When you're dealing with a native input, you're never left wanting for more capabilities from the input than are already exposed by React. And although it has this default behavior, you're still able to completely control the behavior to the needs of your application. Regrettably, when it comes to developing custom componentry, you're usually stifled by having APIs on custom components that don't lend themselves well to complete control, or they're very cumbersome to use because they require you to implement a bunch of logic in order to get it working properly. At least that has been my experience thus far. And a little bit about me. Hi, I'm Justin. I'm into weightlifting, karaoke. I like static analysis and data structures. I would describe myself as being D&D curious. So anyone who has an open spot in the campaign, feel free to slide into my DMs, my Twitter DMs about that. In any case, I was a formal mobile game developer, and currently I'm a front-end developer at ad tech company called MediaMath. And at MediaMath, I work on a team that is implementing a design system. And a design system is really just a collection of reusable, composable, and standardized UI modules. And they're not necessarily implemented in React, but the goal of a design system is really to create a consistent user experience across an organization or even a community. Like the material design system from Google, they hope that all Android developers will, and some of their web developers as well, will sort of use this material design system so that there's a consistent look and feel. And we want to do much the same thing in the applications that we develop at MediaMath. And in addition to that, our design system aims to promote an advantageous set of best practices that will increase tech equity of our code and limit the tech debt as much as possible. And so in order to achieve that, in order to achieve those goals, the components really need to be applicable to a broad range of use cases. And that will typically mean exposing complete control of all the components. And unfortunately, that also means some state management. And maybe my experience differs from most, but the task of trying to keep state management scalable and ergonomic has long been a thorn in my side working with React as a program gets larger. And often I find myself being confronted with more questions than answers. Where should I keep state? Should I keep it locally? Should I keep it globally? Should I use one store? Should I use multiple stores? How am I able to update the state that I need to update when I need to update it. And so in the search for a general solution to some of these problems, and keeping in mind some of the characteristics of React's native input, which is so nice and pleasant to work with, I've got an approach that I'd like to share that aims to do the following things. One, it will expose complete control of a component so that those components are applicable in a wide variety of use cases. And at the same time, it provides the same kind of easy default implementation of its state logic so that it's also really trivial to get started with, to get something on the page and working. So, as promised, this is the approach that I've got. And to see how it works, to show you all how it works, we'll do a short exercise where we build out a little 3-component design system right now. And to spoil the ending, we will be developing a standard component structure that enables a component callback property signature to normalize how state is managed for all components. So if there's one thing to take away from this talk, it would be that there are 2 things to take away from this talk. And the first of those things is the idea that the logic for updating state that is functionally local to a component can be decoupled from the mechanism that stores the state itself. That is, the logic that knows how to update a component doesn't need to live right next to the place where the state itself is stored. And then given that, a component has the opportunity to express to one of its ancestors how it expects its own props to change by default in response to that component's updates, events, right when those events are triggered. So the rest of the slides are going to be a lot of code. There's going to be a lot of code because we're implementing this design system. And we'll be, we'll talk about these things using a couple of terms in mind. So I'm going to use this term actions as a term to describe an object that describes an event. And it will typically have a type label as a string. And then adapter functions, I mean, are just functions that will take one set of parameters and call a function with another set of arguments, so to bridge the gap between dissimilar APIs. Then we have reducers, which are functions that can, using a state and an action, using some value and an action, will give you another next value based on that action. And this should be familiar to anyone who has used Redux or even React's native use reducer hook. And then lastly, there's updater functions, which are just like reducers, only they don't have an action parameter. And so you might encounter these if you've used React's use state hook. Let's see. So any questions so far? Great. Moving right along. So the first component that we're going to implement in our design system is a very simple input like the one that we saw before. That just takes some text. So first we'll start by declaring a functional component. And so we'll call it a value input. And this is going to be, to get started, we'll just render some native input as our JSX. And this is enough to get the ball rolling, but this component right now is totally uncontrolled. And we want it to be controlled. So we're going to have to manage some props. And in particular, we're going to start with non-callback props. So our value input is going to require a value prop that we can pass straight through to our native input. And this means that the parent of this component can totally control what the text in the input is going to be. But in order to respond to user events happening in the input, we're going to need to do a little bit more. So we're going to have a callback prop. We'll call it onChange. It will be a function that gets an event and causes something to happen in response to that event. And in the simplest way possible, we'll just pass that prop directly into our native input. So this is all we need to have a totally controlled value input, which is one of our initial goals. Next, let's try to use that component in an application. So first, we'll render out a value input component, but we will need to pass some props to it. And to support that, we might use a local state hook to set up state for the value of the input itself. We'll pass that value directly into the component, but we also need to handle the change events that are coming from the input. So we'll specify an adapter function to bridge the gap between the callback signature of the value input and the state management hook updater by passing in the event target value directly into the new state. So that's pretty easy. We feel good about the simplicity of implementing this value component, but if we want to reuse this component somewhere else, we have to duplicate an unfortunate amount of code. And some of this code, all the code is very simple now, but in a more complicated scenario, this can get out of hand. And the really troubling code that we want to try to eliminate is this duplication of logic that actually manages the state and the kind of implementation details of the events that are coming out of the value input. It would be nice if we could pull this logic into the component itself so that we don't have to duplicate it. And we can imagine that instead, we could just pass a very generic kind of state management function into the component instead. So let's change the implementation of the value input to accommodate this more ideal API. So looking at this onChange callback, instead of a function that takes an event, we're now going to expect a function that takes a string that represents the state that it intends to update, which corresponds in this case to the value prop. Now, we're going to need to pull in an adapter that we can define inline to pass into the native input instead of the prop directly. So it's a pretty simple adapter function to define, and then we'll just pass it directly in. Now, any questions there? Because it's only going to get better from here. It doesn't look like anything is in the chat, so I will go on. So now, with this new sort of kind of protocol for the expectations of how props should be organized for a component, we're going to define another component with largely the same structure. And this component is going to be a button component. And it will have some behavior where if you hover over it with the mouse, it will show up in a different highlight color. And it will also send some events if you click on it. So now, again, side by side, we're going to build both of these components up from scratch and look at the similarities between the two approaches. So first, we'll declare a functional component. In this case, we'll call it basic button. We'll render out a native button as JSX, and then we'll examine the props that we expect this component to need. We'll start with a label property that will populate the text of the button, and then a highlight Boolean that we can use to drive some of the button style. So we'll just pass those non-callback props more or less directly into the button itself. Beyond that, we're going to have some callback props on the button. And for the button, we're going to have two callbacks handling the mouse enter and mouse leave events. And we expect those to be able to manage a Boolean. which will correspond to the highlight. And we'll also expect an on-click that doesn't particularly do any state management, but it will be able to send a signal to a parent that the button has been clicked. So to accommodate these properties, these callback properties, we're going to need some adapter functions. And we'll specify them in line here, very simply taking the on mouse enter, on mouse leave callbacks and passing in the new value that we expect the highlighted prop to be once those events trigger. And then we've also got an adapter for the click as well. And we'll pass those adapters straight into the button. And that's really all there is to the implementation of our component. So a lot of similarity here between the value input and the basic button. We've got a set of props, some of which stateful, and we've got a set of callback props that know how to modify those stateful props, and adapters that will connect the props that are coming in to the props that the rendered JSX nodes actually need. If we want to consume either of these in an application, we'll start again by rendering out the component, but we'll have to set up some props to pass through. So we'll establish a state slice, in this case for a highlighted Boolean state. We'll pass in the highlighted prop and the state setters directly in. And this feels pretty good because we've been able to eliminate a lot of the need to have adapters in at the point of consumption just to get the basic button on screen and functioning in the proper way. But if we wanted to implement this button somewhere else in our application, we can see that we still got some duplication, and it's a little bit tricky to suss out what the challenge is here. But basically what we have is we've exposed a lot of implementation details about the nature of the property callback interactions between the props of both the basic button and the value input. So on the left, we've got, we kind of have encoded this fact that the value prop is going to be modified by the set value or by the onChange callback. And then on the right side, that this highlighted prop is going to be modified by the on-mouse enter and on-mouse leave callbacks. And it would be nicer if we didn't have to know so much about how each component were implemented. And instead, we just know generally we've got some stateful props. And generally, we're going to have some state handling callbacks that know how to handle those stateful props for the component. This starts to get a little bit cleaner because now there's much less that you actually have to know about how each component is implemented. So in order to be pretty agnostic about kind of how the internal properties of each component relate to the callbacks. And so that's something that we can do by changing the way that we pass state and those callbacks into the component. So we're going to now make some changes to both of our components to accommodate this new API. So focusing in on the callbacks, on change for the value input and on mouse enter and on mouse leave for the button, we're now expecting not functions from individual properties, but instead we're expecting to have functions that expect an updater function instead. And so an updater function, again, is a function that is able to take a prior state to a next state. So when it comes to our adapters, we're going to have to make a couple of changes here. Instead of passing Booleans and strings, instead we're going to pass updater functions. So functions from one state to a next state. And that will patch either the value or the highlighted state as necessary. And so that's a pretty simple modification to do. So the last bit is to, we've had to sacrifice something when we make this change to use the updaters instead of just passing kind of more direct value. We've lost this ability for a parent to kind of introspect what events have happened and why they've happened. And so we can get some of this capability back if we change the signature just a little bit more. And so instead of just an updater function, we'll expect 2 arguments: an action, which is capable of describing an event that happened, and the updater, which is the default logic for making the property update. So in each of our adapters, we'll add a prefix argument that is an action that describes the nature of each. So on change actions in the value input, and then on mouse enter, on mouse leave actions for the basic button. And we don't want to leave our onClick method left out. And it's always nice to have a very consistent signature for your entire kind of property set. So we'll update this to expect an action of sorts as well. And we will pass that action through the onClick callback. So this is our component now. These are our components now. Let's make the changes necessary in the application to support this addition of an additional action. So we are going to need another set of adaptation functions in order to bridge the gap between the set state signature and this action updater pair signature that we had before. So we'll add an adapter, we'll call it manage state. It expects, again, those 2 arguments. And what it will have to do is call set state, again, with an updater of its own that is able to calculate what the next state is. And that can simply be done by calling the updater that we already have. But if we look at the signature of our adapter, we see that we've got this leftover action argument that we're not making great use of. And anybody who's somewhat familiar with Redux will see an opportunity to use a familiar pattern, which is the reducer pattern. So instead of just having an updater function that takes a state, we'll use a reducer that takes a state and an action, and the pair of those will be responsible for creating the next state instead. And this is pretty good. We'll also add a guard to make sure that we actually have a reducer function, because as is the case with our onClick callback, we may not actually want to update the state at all. And then we'll pass in those adapted manage state functions into the props. And it turns out that this manage state function will be sufficient to fulfill any callback, any component callback that fits this sort of signature, which is has a lot of kind of benefits, because now we can actually extract a lot of this logic into its own custom hook. Let's call it use manage state. And the only difference between the adapter that we needed for the value input and the adapter that we needed for the basic button is how it initializes the state, its local state slice, which we can actually parameterize in much the same way that useState does. So we'll make a substitution here. There's an opportunity to use callbacks or refs so that we get stable values that we can try to reduce the number of re-renders. But ultimately, from this custom hook, we'll just return the state and this manage state adapter. So going back to our app, if we want to use this hook instead, we get to pull out a lot of the logic that we had in here. So again, we'll use our state hook, our new use manage state hook, with the properly initialized values, and then we can get rid of the adapter altogether. Now, if we're going to use this hook and the components in another part of the app, there's still a little bit of duplication of logic that it would be really nice if we could get rid of, because we still have to know the precise names of each of the callbacks that can manage state at the end of the day. It would be great if instead we just had, by convention, a single property that we could pass in that will manage state in the default case for all callbacks. And that's not a terribly difficult thing to do if we go back to our component implementations and we focus in on our callback properties. We can add another callback property that is just state manager, and we'll substitute the state manager in for any callback that does not have an explicitly set property. And that will do all of the work for us. Cool. Any questions so far? Let me pull up chat real quick. Oh, yeah, cool. Moving along then, in the home stretch now, we've got 2 components. We were aiming for 3. Here's our 3rd component. And we'll call this the codec field. So this is a field that it takes some text, and you can encode it, and you can decode the text in it. So it combines the 2 components that we've already developed, 2 basic buttons and a value input. So now we get into a little bit of dealing with the composition of components that use this state management style. So if we were to declare a functional codec field component, we'll just render some JSX, again, two buttons and an input. We're going to need some props to handle all of these components, because just like our other components in the design system, we want this to be totally controllable. So the props that we might expect are, 1, the mechanisms by which you would encode and decode the value in the field. And then 2, sets of properties corresponding to each component that, the parent will have to render itself. So field props, encoder props, and decoder props. Okay. We'll plug in those props. We'll pass all those props into the children. But we also need to be able to handle the state for each of those components as well. And so for our codec field, we'll simplify things a little bit by only having this single unified channel through which events get fired, actions and reducers get sent. And we'll need a set of adapters for each child now. So each of these adapters is a state manager in their own right. So a function that takes an action and a reducer and is responsible for causing its own props to change. So we'll pass in those state managers into their corresponding children. And what actually happens in each of these adapter state managers? What happens is we have to call the state manager from the parent, but we're going to have to adapt the property dialect from the props that the parent is expecting into the property dialect of the children. So to take the field, for instance, the field expects to be describing in its reducer how its value should change. But the codec field itself is actually going to have to describe in its reducer how the field props cumulatively change. So we'll have to have a special adapter for that. So what we will do is we'll call our state manager. We're calling the parent's state manager with the same action that we got from the child. But instead of the reducer that we got from the child, which again knows how to talk about how a value should change, how a value prop should change, we're going to pass in our own reducer. And our own reducer is going to call the child reducer now, passing in the props that are at the dialect of the child level and the action that came from the child. And calculate basically the next props that would be for the child. Then lastly, it's going to plug in that new set of properties for its child into its cumulative sort of property set. And the other adapters are actually going to do almost exactly the same thing. Kind of bridging the gap between the reducer that knows the state dialect of the child to the state dialect of the parents. The only difference between these three methods at this point is what part of the parent state gets passed into the reducer, and what part of the resulting state gets updated as a result, which is kind of nice. But the encoders are actually going to need something a little bit more, because they also have to handle some other events that don't necessarily update state themselves. The buttons don't know when they click how state should change as a result. Instead, a click on the button intends to change ultimately the field props that are coming into the codec field. So we'll establish a state management reducer for that purpose. There's a lot of code here. The most significant bit is that we'll take the last value that came in and encode it and pass it out into the value of the next field. And we'll have to do a very similar thing for the decoder, handling the click on the decode side, which will just decode the last value to produce the next value. And that will bubble all the way back up through the parent reducer and come back through its props. So there's a lot going on here. Admittedly, this is a lot of code, but the value here is that now all this code is contained within the component itself. This is code that you might have had to write yourself if you're hoping to consume this codec field in one or more places in your application. But now you're able to reuse a lot of this code and leverage the fact that there's just kind of a default implementation that each component kind of provides to its parent. So in an app, again, we use that same hook. It's the same use manage hook that we were using in our application usages of the value input and the basic button. And we're just able to kind of naively pass in the state and the state manager and get a component on screen that's just going to work out of the box. Let's pause one more time for questions.
Yeah, it looks like we got a question here from Jeff.
Howard. What are the advantages of this technique if this is used once you run into maintenance issues when a programmer who's not familiar with this has to fix a problem or update the code? Certainly this is, I will just speed through to the end where I kind of talk about the benefits and drawbacks of this approach. So on the benefit side, certainly it is a systematic way by which you can offer total control of a component, and it's got a consistent and uniform API, which makes it really easy for users to consume. On the drawback side, it is a little bit more involved to produce, and as Howard asked, it is a bit of an unfamiliar pattern. There will be a bit of a learning curve to get used to this kind of thing. But Howard, to address your question, I think that this is a style that benefits from the convention. And once you know the convention, you can go into any component and expect to see the same patterns existing throughout all of the components that are implemented in this way. So it will take a little bit of onboarding time to get used to the approach, but once you do, it helps you. I think that you'll actually get benefits out of being able to make changes quickly. Certainly, another of the drawbacks is that there's still a lot of, it's a novel approach. There's a lot of room for improvement. I already have some ideas about how to clean things up. So there is a challenge that this might not be a thing that everybody should just go out and adopt today. Again, the things to really take from the talk are these two kind of ideas that the reducer, well, that the state doesn't have to, the logic for the state does not have to live where the state is actually saved, and that a child can communicate to its parent kind of what the default implementation, what it expects as a default implementation that can be overridden as you might want to do later. So things to look at in the future, how to make it actually more ergonomic to compose components built in this style together. There are a lot of ideas that I have there to kind of reduce the amount of boilerplate ultimately that you have to go through to set one of these up. There may be an opportunity as well. At MediaMath, we have used Redux Saga to some effect, and being able to handle kind of asynchronous side effects in a component architecture like this may be of some benefit, or if you have to manage like timing of animations that need to be managed. And then lastly, I've been keenly interested in trying to figure out ways to use state charts or finite state machines in a way to ultimately be able to have more reliable component infrastructure, and then ultimately be able to like visualize how a component system can interoperate. Because I think those sorts of tools make it a lot easier for people to learn how the pieces all fit together. With that, I'd like to thank my colleagues at MediaMath who give me the space to explore some of these novel ideas, which I really appreciate, and putting up with my shenanigans. And then I'll ask for any last questions one last time.
Do you have any like goals for open source or maintaining this or publishing it?
I do have goals. This is about a 70% solution to the problem, and I am in the process of working on the next 20%. But I will say that you don't need much to leverage the pattern itself. As you've seen, we're kind of able to bootstrap the whole thing right now. The shareable bit is really in that use managed in this use managed state hook. This is the shareable bit, and it ultimately boils down to something like 20 lines of code that I would encourage anybody to even try to write for themselves to get a better understanding of how that all works. Here we go. Yeah. So yeah, this use managed state is really that's the kernel of the shareable logic. Everything else comes down to kind of a convention, the convention by which you design your component APIs so that they are controllable in a consistent and kind of modular way.
Mm-hmm.
Have another question in the chat. I like the consistency of the API, but doesn't this approach separate the state of the component from the component? Which is your point.
This was me more like talking it out. Like, I like to co-locate my business logic with my markup, and you're doing that. But I needed to like get to the point where like updating the state is different than actually storing the state.
Yeah.
And that was not intuitive. So like that's the last part of it.
That is the key. Yeah, that's the key to this approach, is that you still kind of get to have your cake and eat it too a little bit. You can keep all that logic right next to the component where it's easy to draw the connection. Like one of the challenges that I've had with Redux at times is that you're jumping through a lot of different hoops to find out when you dispatch one action, how does it actually affect the thing that is going to get fed back in props at the. So you're jumping through like 4 or 5 different files to try to connect those dots. But with this approach, you can have the logic, like in many of the components that we're using in our design system internally, we'll have a reducer defined right there in the file next to the component that gets exported. And we just pass that reducer along with every action.
Cool, thank you.
Oh,
I wanted to ask, are you open to questions through emails? Because I think I'm going to have to look through the recording a couple of times just to get, like, just to know what questions I need to ask.
absolutely. If you are so inclined, you can email me at justin@jcmore.dev. I'll throw that in the chat.
Awesome, thank you.
Yeah, so if there are no other questions, thanks everybody for your time and your patience while my computer was feeling a little finicky.